Okay, so next 9 we can see. So these are very important examples. Okay, so pay attention very properly. Only 2 examples we are taking because it is going to take some time. I'll take some time to explain it properly. Okay, fine. So let's see plane of symmetry. So this is Fischer projection. If I see this one, if I cut it from the center, I can see OH in front of OH, H and H in front of each other, and CH3 in front of each other, right? So that is plane of symmetry. It is there, we can see. I can cut it in half. So there is plane of symmetry. What about center of symmetry? So if I talk about center of symmetry, I need to find a center. So let's go to the center. So suppose I go here, I see that if I go this side I get OH, but going back side I get H. Similarly this side also OH, this side H. So what do we feel? That there is no center of symmetry. But is it really so? So the fact is that it does contain COS also, but we are not able to see center of symmetry in Fischer projection, and that is one difficulty we face. So what you are going to do is, we are going to convert this Fischer projection into sawhorse projection, and we have to do it mentally, and it's very easy. Look with the model, see. Now in Fischer projection we know that these horizontal bonds, they face above the board, right? Horizontal ones are above both, and the vertical ones are going behind the plane. So if I use this model, how I am going to do? So look, these 4 groups are coming outside. So you look, can you see this? So this blue, red and blue, this blue, they are coming out above the plane, and this both greens are going behind the plane, like this. Okay, and if I have to draw the Fischer projection, how I am going to do is, I will take this and I press this on the board. So you can see, if I press this, right, like this, so you can see I am going to get Fischer projection. So basically it is like this. Okay, so what I am going to do is, I am going to take this compound like this, and I am going to view it from other angle. And how to do it? So I will take this and then I am going to put it like this. You see, it is green. Okay, so take these 2 carbons and put it like this. Okay, again I will just show you how you have to do it mentally. We are going to take this compound, okay, and then putting it like this. Okay, so like from here to here, we are looking from sideways. If I look it from front, from this side, it becomes Fischer projection. Okay, but if I look it from sideways like this, it is going to become sawhorse projection. That is the only difference. Okay, so you see, when I will bring this compound from here to like this, the shape, pay attention to this, it is Y kind, Y, X, Y, Z, Y, here also Y, and that is the trick. Okay, and you see the right ones, the right groups, these blue, are going to come above the plane, right? And these both hydrogens which are on this side, they are going to go behind the plane, and that's the only thing we have to remember while converting it. Okay, just see how. Suppose I have to draw, so what I'll do, I'll convert this. So remember it, draw horizontal, draw Y. Okay, this bond is coming outside above the plane, and this is going backside behind the plane. What I told, right ones, these go above the plane, okay, and these will go below the plane, will go below the plane. Remember, I am writing this for sawhorse. Okay, I am writing all this for sawhorse. Okay, and the vertical ones, just put it down. So CH3 here. Right side will go above the plane, which is this one, which is OH and OH. Okay. Okay, if I just tell if this is carbon number 1, carbon number 2, here which are number 1, number 2, so that also is important. So remember, like this and like this. So this one is carbon number 1 and this one is carbon number 2. Everything we should copy correctly, okay, don't do any mistake. So OH, OH, so what is left is HH. Fine. Now I have to check only for center of symmetry. Now look here. To check center of symmetry, what you have to do is, now you see, suppose this is the center. So this CH3 is this side and this is in the plane of the board. So I must have CH3, this CH3 I should be having here to check for center of symmetry. So we are going to arrange it accordingly to check best for center of symmetry. How I am going to do? I am going to take this CH3 and put it here. How will I do that? I will rotate this carbon. Rotate this carbon by how much degree? So now just imagine, try to imagine. So CH3 is like downside in this plane. I have to take this and put it in this position. That is how much angle? 180 degree. So I am going to rotate it by 180 degree angle. Clear? Now while rotating, remember three things. What? Let me show you again a molecule. See, whenever I rotate, and this is very important because we have to use it further along, okay? This is YY, okay? So let it bring in YY. So see, this is YY. What I'm telling you is, let me bring like this, green, okay? What I told is I want to bring green in plane with green, like this. But in doing so, you have to keep something in mind. We cannot do randomly. What? So I will be rotating it like this. Done. What happened to the other two groups? Pay attention to that. Before rotation, navy blue was behind the plane and this was in front. When you do 180 degree rotation, 180 like this, so the back one comes in front and front one goes in back, and the one which was in the plane remains in the plane. Green was in the plane here, right? Green was in the plane. After rotating 180 degree, it will be in the plane. But above goes below. Below comes above. Right? So if I have to write here, just for your hint, okay? So remember what? That 180 degree rotation, above becomes below, below becomes above, and in plane remains in plane. Okay, see, all these things you just keep in mind, so everything becomes easy. Now rotate it. After rotation, how can I draw? So just draw this one. Here we have done no changes, so I can draw it like this. This is what? OH, this is H, this is CH3. Now this is above the plane and this is behind the plane. Here CH3 is going to come this side, so you see, above the plane and below the plane. Now below will come above, above will go below. Done. It should look like YA form, okay? It should look like YA form like this to check for center of symmetry. Then what we are going to do? Simply check. So you see, I am moving in the plane, I get CH3. I go in the plane backwards, I get CH3. I go above the plane, OH. So if I am going above the plane, its 180 degree will be opposite, will be behind the plane. Clear? So above and below, below, above. Okay, I hope that point is clear, right? So if this is a plane, if you are moving above the plane, its 180 degree will be behind the plane. So therefore I am getting everything. So center of symmetry will be there and plane of symmetry is also there. Therefore this molecule is achiral or optically inactive. Fatafat, let's try this one. Okay, very simple trick how to convert into sawhorse. First of all, let's check plane of symmetry. So I'll cut it. HOH, is there any plane of symmetry? No. So no plane of symmetry. How about center of symmetry? We cannot say in Fischer. I'll draw sawhorse. How will we draw? So first just draw this one line, YY. This is coming outside, this is going backside, outside and backside. If this is carbon number 1, carbon number 2, so carbon number 1, carbon number 2. Done? Half of your work is done. Then what will happen on carbon number 1? H. So H will be coming outside. This goes outside. remaining just put, so OH, H, OH. Here CH3 top ones always come in the bottom. Done. CH3 is in the plane. I have to rotate this by 180 degree. So I will take this and rotate it by 180 degree. So if I do that, what I'm going to make, look here. So again, here I have not changed anything. Here CH3 will go above, below and above. Done. Here just put, it will be CH3, H, OH. Here CH3 will go on top, right, 180 degree. Above will go below, below will come above. Done. Now simply have to check. So if this is your center, going in the plane CH3, going in the plane CH3, above H, below OH. Don't come here, both are above. Okay, if both are above like this, how can you go from here and then again in this direction? You cannot. Similarly, below OH but above H, above. Below to above will go, not same. So therefore there is no center of symmetry as well. Therefore the molecule is chiral or optically active. Simple, right? Okay, just write one final point. COS cannot be identified in Fischer projection. Okay, but POS can be identified. Okay, so just remember, whenever you will get Fischer, to find POS you can do, but for COS you will have to convert into Shekhar. Okay, and this is the method for conversion and this is the method for rotation. Okay, use your imagination and you will be good to go. Clear? Let's move to another set of example. Okay, so if these two are given, then what you have to do? So see, this is nothing but whatever we had seen, which was like this. Now they have just given like this. So we don't have to worry. Okay, you have to just realize it. So now you see which form is it? It is from here and 2 down, meaning A. This is A kind and this also A kind. Okay. Now, if you have to see plane of symmetry, we can directly see here how. If I cut it like this, so see CH3 in plane, front of each other, above the plane, meaning if I just show you, right, so if this OH is up, this OH is also up in front of each other, and H and H, they are at the back, so they will be at the back like this. So OH in front, H in back, right? So if I cut it, everything will be like mirror image. So POS is there. How about center of symmetry? So can I see center of symmetry in AA? No. Okay, because if this is here, I want this one to be down. So what I am going to do, I will just rotate it. Okay, so suppose anyone you can rotate. I am rotating, let's take this one. By how much angle? 180 degree. So after rotation and rotating it, suppose clockwise, right, or anti-clockwise. So 180 degree, I have to just rotate. It's very simple. First draw Y. So it will be, this is A kind, here Y kind, how it will look like? Just like this, right? So put here, it will be CH3HOH, CH3. Now which was above will go below. Above was OH, so above will go below. Below was H, so it will come above. Very simple. Now you try to find COS. So here is the center, in plane, CH3, CH3. Below the plane and above the plane. Similarly, above the plane, so below the plane. Right? So I am getting everything same. So center of symmetry is also there, both. So therefore it will be achiral or optically inactive. Are you understanding? 12th one you see. So this is what form? You see, this is A kind. Okay, so it is drawn like this, that side. And if I see this one, it is drawn in this fashion. Right? So if I take this to be A, so it is Y. Clear? Fine. So if this is A and Y, I can find COS in this. Okay, but not POS. So what I'll do? First check COS. Okay, from here I go up, I get H. I go below. Now you see this one H is below only. So therefore I am getting it. Then I go in plane CH3, in plane CH3. Done. Then I go below the plane OH and above the plane OH. So therefore COS is there. What about plane of symmetry? So for plane of symmetry I have to have AA or YY. Okay, not AY. So I have to rotate. So suppose I just rotate this one. Okay, I'll draw with black. So this one I will rotate by 180 degree. This one I am not touching. So simply draw this one. It will be what? CH3. Then one is above and one is below. Above is OH, below is H. Rotate this one. So this one is going to be in plane. So like this, CH3. One above and one below. Below will come above. Above will come below. Done. Now simply check POS. So if I cut it like this, CH3 in front of CH3, OH above, and here also OH above, both will be in front. So fine, with OH also fine. H below, H below, this also is fine. So here also I am having both, right? So if I am having both, this compound is going to be achiral or optically inactive. It's that simple. Done. Okay, write fast. I'll write some more. Okay, now let's check here. See, this is a triangle, right? So in this CL, can you see in a plane of symmetry? Okay, so these kind of questions where we have ring. Okay, let me show you just one example. Okay, see this one. So here it looks like this. Okay, these both are CL. So what you have to imagine? So this is ring. I can take any plane I want. So obviously I want two groups to be in front of each other. So I'll take a plane of symmetry, right? You can see this is the mirror, and then they are going to be mirror images, and this is going to be half. So in front of each other. So therefore this is a plane of symmetry, right? If I attach one group here like this one, so then this one can be example of 14th one or 15th one, right? In this case, how will we take plane of symmetry? So now remember, if I take like this and cut it like this, so then blue and red, they will not be mirror images. So I obviously want blue and blue. So I'll cut it like this, red half and blue in front of each other. Very simple, right? So let's apply it here. So if I talk about plane of symmetry, what do you think? I'll cut it like this as I showed you, right? Triangle is like this and we cut it like this. So CL in front of each other, HH in front of each other, plane of symmetry will be there. How about center of symmetry? Now you see center, you go anywhere. If I'm going here, I go above the plane, I get CL. I go below the plane, I know where I have CL below the plane, right? Anywhere you can take. Here also if you take above CL, below H, so it's not matching, so therefore no center of symmetry. How about this one? So in 14th, again, how will you cut? Will you cut like this, or like this? So I'm going to cut it in this manner, so that OH will be half and CL in front of CL. So this will be your plane of symmetry. So there will be plane of symmetry, one plane of symmetry. Understood? How about center of symmetry? Again, if I go above CL, there is no CL below, nowhere. So again, no center of symmetry. So this will be achiral, this will be achiral or optically inactive, right? Very simple. 15th one. Okay, let me ask you one question. How many chiral carbons are there? How many chiral carbons if I ask you? What will you answer? So 1, 2, 3. Is this chiral? Both sides I have CL, same group. Is this chiral? What will you think? So it is chiral depending on their orientation. Right now it is not chiral, but if I just change this CL up and down, orientation of these two groups, if I change, this carbon will become chiral. It means sometimes chiral, sometimes non-chiral, so it becomes pseudo-chiral. So overall 3 chiral carbons are there. 3 chiral carbons. Out of that, 1 is what? Pseudo-chiral also. Out of that 1, okay, not 3 plus 1. Inside this 3, there is 1 pseudo-chiral, which is this one. Okay, just for revision. 15th one, you see here it is H. Here it also put Cl. Okay, so Cl, Cl, Cl. I can take any 2 Cl, I can cut it like this. Right, so there is plane of symmetry. How about center? Anywhere center? No, above Cl, but there is no Cl below. So there is no center of symmetry. So no center of symmetry. Understood? How about if I ask you how many chiral carbons? So 3 chiral carbons, and how many pseudo-chiral? So therefore all 3 are pseudo-chiral carbons. Okay, here all 3 pseudo-chiral. Right, because if I take this one, Cl and H will be different, but if I go that side, ClH, this side ClH, same. But if orientation, if I change, then they are going to be stereochemically different. It will become chiral. So 3 pseudo-chiral carbons. So POS is present, therefore it will be achiral or optically inactive. Very simple, right? Write first, I'll write some more. Okay, let's do in this. Very simple. What do you think? Plane of symmetry is there? Yes. How? I will cut from this. Okay, I'll take a plane and cut like this, so that Cl will be half of, H will be half of. You can imagine. So a square is there, I'll cut on the diagonal, that plane. So it will bisect chlorine, and this also. Okay, I can take this also, no issue. If I take this also, then also they are going to be in front of each other, just like mirror images. So there is plane of symmetry. How about center of symmetry? If I take this, I go up, I'll get chlorine, but if I go down, I'll get H. So no, there is no center of symmetry, but still it is achiral or optically inactive. How about 17th one? Now, is this your plane of symmetry? If I cut like that? No. Why? Because H and Cl, they are not going to be mirror images. So therefore, I'll cut in this fashion. Right, in this. Okay, so this will be my POS. Why? It will cut chlorine and H and chlorine just half in front of each other. So therefore, they are going to be mirror images, that is plane of symmetry. How about center of symmetry? Do we have? So just check. From here, if I go above, I'll get chlorine. I go below, I'll get chlorine. Go above H, go below H. So therefore, center of symmetry is also, they can go anywhere. You go here carbon, go here carbon. So it will be achiral and optically inactive. How about 18th one? Is there any plane of symmetry? Will this be plane of symmetry? No. Again, BR and F, not mirror images. Then what I'll do? I'll cut it like this. Okay, so that it will cut this sphere in half, and half. Right? It will cut like this, slice it. So 2 slices in front of each other. So therefore, there is plane of symmetry. Which one? This one. Okay, so this is your plane of symmetry. Cutting it like this. So what about center of symmetry? Obviously, there is no center of symmetry, right? So this is also achiral and optically inactive. How about 19th one? Do you see any plane of symmetry in this? What do you feel? If I cut it like this, diagonal, right? So it will cut COH, H and COH half. That is fine. But then in front of PH, who will be there? H. So that's not a plane of symmetry. How about this one? If I cut in this fashion diagonal, so then in front of COH there will be H. So again, no, not same. Therefore, no plane of symmetry. How about center of symmetry? From here, I go up, I get COH. I go down, I get COH. I go up H, I go down H. Similarly, I go up phenyl, I go down phenyl. Understanding? And same goes for H. I go down H, I go up H. So center of symmetry is there. So therefore again this will be achiral or optically inactive. Okay, I'll just read 2 more examples and then we are done. Okay, so these questions, they look very beautiful, right? Okay, so let's try in this plane of symmetry. So what I'll do, this carbon is going up. Now you tell me, can I rotate this carbon? Can I rotate this carbon like this and I bring it down? Can I? No, right? If you have seen geometric videos, you'll understand that double bond is a restricted rotation. If you are feeling that, sir, I'll rotate it, I'll put it down, make it something like this, and then I can check. So you are wrong, because this bond is not for rotation. This is double bond, restricted rotation. You cannot rotate along that bond. So therefore it is this what is given. You can't do anything. So it's very simple. Complexity reduced. So if I try to find plane of symmetry in front of this carbon, I don't have anything here. So no plane of symmetry. How about center of symmetry? So from here, I go above the plane, I get H. Then I go below the plane and I get H. I go below the plane, OH, above the plane, OH. In plane, CH3, in plane, CH3. So center of symmetry is there, but still it is achiral or optically inactive. Right? Very nice. 21. Try it. Tell me. What do you think? So I will cut it like this. In front of this, there is this group. Is it mirror image? Yes. Why? Because H is going backside. Here also H is going backside. Right? Like this. OH coming in front. CH3 in plane. So they are in front of each other. So POS is there. POS. This is COS. How about center of symmetry? So definitely if I am going here above the plane, I should be going here below the plane. Nothing is there. So there is no center of symmetry. But still it is achiral or optically inactive. Okay, right? So we have done lots of examples now, right? 21 examples, different types of examples. It should be clear by now. Okay, I hope, and it is clear. You can try more questions from your material, whatever you have. If you have any doubt or any section you have any issues, just comment it down. In the next video, I'll be trying to take up that issue. So I hope, so this session is up to here only. In the next session, since we know how to find plane of symmetry and center of symmetry, on basis of this, now we can define what is enantiomer, diastereomer and mesomer. Okay, so meso compounds, enantiomers and diastereomers we are going to complete in the next video lecture, the most crucial part of this. Okay, on what the questions are asked. So I hope you enjoyed it, and if you really liked it, then please hit the subscribe button so that next time, the next portion, as soon as it gets uploaded, you get that notification. So thank you, and we'll meet in the next video.